Section 6.4, the simplex method, standard maximization problems. So if you haven't done so already, go ahead and print out the notes, or at least have them available to you to look at on your laptop or somewhere. For this particular section, I'm not going to go through the notes page by page, but you should look at the first 4 pages. And then after you've read through the first 4 pages and kind of thought about what's going on there, go ahead and watch the rest of this video, because what I'm going to do is I'm going to summarize what was being said there. So whether you look at that or not, you're going to get a good summarization right now. So I'm going to go ahead and begin example number 1. Okay, these types of problems we've seen before. We've looked at them in the previous section, 6.3. The difference is this is a more probably streamlined way, a systematic way of solving a linear programming problem. We're also able to, unlike the graphical method, using this method, we're able to come up with any leftover raw materials, for example, if we're looking at a word problem. So there are advantages to using this method, but honestly, if you are in the real world, which people are obviously in the real world right now doing modeling, look at where we are with COVID-19. They're doing different modeling and looking at different data all the time. You'd probably use a software like Excel, for example, to work these out. We're not going to be using Excel. We're going to be using pencil and paper, or in this case, pen and paper, and the theory in math that allows us to do this, okay? So, looking at the first problem here, we're going to maximize this objective function subject to these constraints. Again, this tells us we're only looking at quadrant number 1. All right, so the first thing we want to do here, and here's where my summarization comes into play. The first thing we want to do is introduce what are called slack variables. We're going to be introducing what are called slack variables. And our slack variables are going to be represented by the letters U, V, or W, okay? So if we look at this first inequality, what a slack variable allows us to do is to rewrite this inequality as an equation. And so for each new inequality, you're going to add a new slack variable. So this one could be rewritten as x plus 2y plus u equals 12. All right, notice the use of the u in our first inequality. So this is just allowing us to recognize that, if we did not use all of x or y that we could possibly use to make it equal to 12, this would make up that slack. This allows us to create an equation. If you don't fully understand that, or if I didn't explain that well enough, I apologize. But as long as you know to introduce a new slack variable for each new inequality, you are going to be good with step number 1. All right, so that's step number 1. The next step, step number 2. In step number 2, we are going to rewrite the objective model, which, objective function, objective model, whatever, it's the maximization function that we're looking at. So we start off with our maximization model as p equaling 10x plus 12y. And what we must do, based upon the guidelines set forth within the simplex method, what we must do is set this equal to 0, okay? So to set it equal to 0, we're going to move all of our x, y, and z, whatever, so on and so forth terms, from the right to the left. You have to leave p alone, all right? Leave p where it is. So you're only going to be moving these terms from the right to the left, which will give us what? Negative 10x, and then what? Minus 12y plus p. So there's the rewrite of our objective model. That completes step number 2. The final step here, in terms of initially setting up a linear programming so that we can use the simplex method to solve it is to actually create your simplex table. All right, create your simplex table. All right, after we create our simplex table, we're going to use row operations and a couple other principles as well to ultimately solve this linear programming problem. Okay, so let's go ahead and create the table now. Our column headings for our table will be X, Y, and then our slack variable column headings will be U and V. We only need 2 in this case because we only had 2 given inequalities. And then you're going to have your P column, which is your maximization column. And then you have your column of constants, C. So what we want to do is put a horizontal segment underneath those column headings, and then put a vertical bar splitting between the P and the C. And then what we're going to do is come up with the values in our first row. So notice what we're actually creating here is an array of numbers, which is really a matrix. So what number would go here? Well, look at your first step. Look at these 2 equations that we came up with after we introduced our slack variables. So first equation, this means 1x, so you put a 1 right there. And then plus 2y, so you put a 2 right there. And then plus 1u, put a 1 underneath the u. And then there's no v here. There's no v, so this is a 0. There's no p, so that's 0. And your constant is 12. So that's what you're going to put in this matrix, in this table, in this simplex table. Okay, with that being said, the second equation would generate what? 3, and then 2, and then note there's no u here, so you put a 0. There is a v, so 1v, no p, and then 24 is your constant. Then you're going to put another horizontal bar, and this final row is going to ultimately give us what will be our maximum value, okay? So this final row is therefore based on the objective model. Now remember, you don't use this one, you use the one that you rewrote setting it equal to 0, okay? So again, remember I told you don't move the p. Just move these terms from the right to the left to set this equal to 0. And that would give us what? It would give us -10, -12. We don't have any u's or v's here. We do have a p. And then we have a constant of 0. Note what just happened underneath the u, v, and p columns. You ended up with the identity matrix. That's something that will always happen. That's 100% of the time. Okay, the next thing we want to do after we've created the table is solve this thing. We want to solve this linear programming problem using the simplex method. So everything we've done thus far is just setting up the thing, setting up the appropriate simplex table. The next thing we're going to do is look at the steps required to actually solve this thing using the simplex method.